Hi guys, how's it going? I am in sunny San Diego right now, but I am still here teaching you at the same time. So what we're going to do today is go over our study guide that you completed in class yesterday. And so I want you to stay focused, pay attention, stay right with me, and make sure you study hard because tomorrow is going to be your test. Okay? All right, so question number 1 says, what is the SI unit for each of the following? You can use page 285 in your textbook, which, yes, I know we only really use when I'm not around. That's not 285, but this is. Let's see. 285. Here we go. If you're not sure about what SI means, International System of Units is SI, a system based on the number of 10. Here we have the basic SI unit of length is the meter. We can also acceptable would be centimeter or millimeter. So let's go ahead and fill those in. All right, so length, like we said, was going to be the meter. And then also acceptable would be the kilometer or the centimeter, or if you wanted to go small, millimeter would be appropriate as well. I don't really like that pen that much. I'm going to try this one. Okay, so mass is going to be the gram. We would also accept kilogram. Volume is going to be the liter. And I would also accept a milliliter. And then force, which is our relatively new one, if we go to our notes on Newton's law that we took last week, we would see that in fact it says right here, 1 Newton is equal to the force required to accelerate 1 kilogram of mass 1 meter per second per second. Here's the bottom line. The unit of force is newtons, and we abbreviate that with a lowercase n. So Newton. I said lowercase, I meant uppercase. You know. Okay. So next up, it says, what two variables are shown in the graph above? When it's asking about what two variables, what I want you to do is just focus on what the titles for the x and y axis are. Okay, so in this case it is distance and time. Next up it says, how far did the runner go in the first 3 seconds? By the way, let me just make sure you had enough time to copy all of that down. How far did the runner, I guess you can press, you can't really press pause because we're going to do this everybody all at the same time. Alright, anyway, number 3, how far did the runner go in the first 3 seconds? So, if I want to know how far the runner went, I go over here on the x-axis, 1, 2, 3, it says in the first 3 seconds. Then I climb up here, up the y-axis, and I follow this. It says 15 right here, but it's a teensy bit higher than 15, so we're going to go 16. And then you ask yourself, 16 what? And we look carefully right here, we see that the unit is 16 meters. So our correct answer for number 3 is 16 meters. What would be a good title for this graph? Alright, so in some kind of capacity, we want to incorporate this distance and this time. We know that distance and time can be incorporated with one word using speed. So I'm going to say speed of a runner. There's obviously a lot of correct answers for this one right here. As long as they have something to do with distance and time, then we're good to go. I'm going to slide that on up. Alright, next up, it says write the formulas for the following in words, not just letters. Okay, so if you just got letters, you are not following my instructions. Alright, step 1 says to go to page 286. But for reals, you should already know what the formula for speed is without looking. But Jay, I see you need it. Bam! There it is. Speed equals distance divided by time. So we're going to write that carefully here. Speed equals distance divided by time. And recall from this right here, alright, got to know it, alright, speed equals distance divided by time, right there, Distance divided by time. All right, next up, it says velocity. What is velocity? And that is going to be the same exact definition as speed, or formula as speed. The only difference is, in this case, it's going to be speed in a specific direction. So we are going to write velocity equals distance divided by time in a specific direction. So here's the deal with velocity, okay, and we can see it right here. S equals d divided by t. We flip on to velocity. Bam. Good news. Since velocity is speed in a particular direction, the formula is exactly the same for both of them. So speed is distance divided by time, so too is velocity. It's just in a specific direction. Okay? Alright. Let's go here. I don't like that. Okay. Let's go here, yeah? No. Alright, one. Back in business. Alright, acceleration. Here we go. Got acceleration on page 304. So we flip to page 304. And we find acceleration equals final velocity minus initial velocity divided by time. Okay? So we have acceleration equals final velocity minus initial velocity divided by time. Okay? And again, if we recall, our acceleration, which is right here, recall this is like if we were to write this in just using letters, it would be acceleration equals v final, and that F stands for final, and initial is initial. Okay, remember that if we have final is like what the velocity is at the end. Okay, and the initial is what it is at the beginning. Again, if it's starting at rest, then that initial velocity is gonna be 0. All right, last but not least, it says, for number 5, it says force. What's force, which is, of course, Newton's second law of motion, which we would find on page 321. So we flip-a-rooski. Oh, hang on, I don't have the correct thingy up here. So we go here, and on page 321, force equals mass times acceleration. All right, so we go here, force equals mass times acceleration. Okay, and again with our Newton, that is Newton's second law of motion, and we learned in Newton's second law of motion, it's basically just a what's that thing called? A formula, basically, right? F is force, M is mass, and A is acceleration. That is Newton's second law of motion. Force equals mass times acceleration. All right, next up, it says define gravity. We haven't talked about this one as much, but we do need to kind of recognize the difference between mass and weight, and so in order to do that, we need to understand what gravity is. Okay, gravity is on page 326, and it states gravity is the force that pulls objects toward each other. Okay, so we go down here. Gravity is the force that pulls objects toward each other. Okay, weight is on the opposite side. We see that weight opposite side of this paper over, or this textbook over here. Weight is a measure of the force of gravity on an object. Okay. Weight is a measure of the force of gravity on an object. Okay, and our formula for weight we find on page 328 is, that's the following page over here, weight equals mass times acceleration due to gravity. Weight equals mass times acceleration due to gravity. Okay, mass we also find on page 329, although, whoops, not 329, 327. Even though I didn't write it here for you, you would have been able to see if you had actually looked up weight, you would see that the very next sentence right here, it's actually the very last sentence on the page, mass is a measure of the amount of matter in an object. Mass is a measure. What is going on there? Not really sure what that thing is. I don't know if you can see it. But oh, there we go. Okay, alright, yeah, we're good. Alright, mass is a measure of what? Of the amount of matter in an object. Okay. Next up, what's the difference between mass and weight? Okay, here's a bottom line. Weight takes into account gravity. Alright, here's the bottom line. Weight cares about gravity. Mass does not. So what do I mean by that? Mass and weight are the same value on Earth. But mass and weight are not the same on the moon. Because gravity is different. On the Earth and moon. Okay, so you've heard this before, right? So you go, if you were living on the moon, then you'd weigh a whole lot different than you would here on Earth, right? Same thing, like if you lived, like for example, I'd be weighing a whole lot less if I lived on the moon. You know, I wouldn't have all the needs, like everything that I needed, but I'd weigh a whole lot less. Now, when it comes to Jupiter, though, okay, Jupiter is, like, I would be weighing a whole lot more because Jupiter has a whole lot more gravity associated with it, okay? All right, number 11. Define force. Force, okay, if you were not sure what a force was, then you could look in the glossary of your textbook and be resourceful and find out that a force is a push or a pull exerted on an object. A push or a pull exerted on an object. Okay, so I want you to take a look, kind of zoom in on this. And that's the front.